This beam AB is a simply supported beam having hinge support at point A and the roller support at point B. And there are two forces. One is vertical force of 60 kN acting at point C and another force 100 kN acting at point D. And this force is inclined at certain angle. So in order to find the support reaction for this particular beam, we need to draw the free body diagram. So this is free body diagram of this particular beam. Okay, so in the free body diagram we do not show the supports of the beam, rather we show the forces acting at the support. So this one is called as the free body diagram. So if you look at the free body diagram of this beam, since at point A we have got hinge support, there shall be two reactions. One will be along horizontal direction and other will be along the vertical direction. Point B is having roller support. So here we have only vertical reaction over here because roller will not support any kind of inclined load. Okay, so here we have got an inclined load of 100 kN. So before finding out the support reaction of this beam, we shall resolve this inclined force into components. One is vertical component and horizontal component. So let's say this is the vertical component of this force, friends, like this, and it will also have a horizontal component here like this. So for that we need to find this angle, friends. So let's find this angle first. So this angle, let me say this angle is theta. So from this geometry, if you see, they have given the geometry to us. So this side they have given as 3, while this side they have given as 4. So if this angle is theta, friends, so we can find out theta equals tan inverse of opposite side is 4 and the adjacent side is 3. If you calculate this, the value of theta will be 53.13 degrees. Okay, so this angle is 53.13, so therefore this angle will also be 53.13. So we got this angle, friends. Now we can resolve this force 100 kN into horizontal component and vertical component. So this horizontal component will be given as, since this angle is theta, for instance, this will be force times cos theta. So it will be 100 cos theta, that is 53.13. And similarly this component, the vertical component, will be 100 sin theta, that is sin 53.13. So we are able to resolve this inclined force in vertical component as well as in the horizontal component. Now to find the support reaction, we shall be only considering this horizontal and vertical component. So to find the support reaction, I am going to use the condition of equilibrium. So by condition of static equilibrium, so we know that the condition of static equilibrium is the summation of forces in horizontal direction is 0. It means all horizontal forces are balanced. Summation of forces in vertical direction equal to 0, and summation of moment of forces about any point on the beam equal to 0. So that is summation of moment of forces. I can take point A just for simplicity. Okay, so these three conditions I am going to use. So first of all, let me use the summation of forces in the horizontal direction, that is summation of fx equal to 0. So I am going to use this condition first. So therefore summation of forces in horizontal direction is 0. So let me write down the horizontal forces. So this is horizontal force, friends, RAX, right? And next horizontal force is this one, 100 cos 53. So we have only two horizontal forces. Okay, so I'm going to consider only these two forces. So I will say RAX. So RAX I am taking positive because it is acting towards right, and this 100 cos 53.13 I am taking negative. This is acting towards left, that is why I have taken a negative. So if I solve this, I can find out the value of RAX as, therefore RAX will be 60 kilonewton. This value is going to be, friends, 60 kilonewton. So friends, now we'll be using the second condition, that is summation of vertical forces equal to 0. So we have this vertical force, this one, and this. So there are four vertical forces. So summation of these four forces is going to be 0. So let's see how we can apply the second condition, that is summation of forces in the vertical direction equal to 0. Y stands for vertical forces. So RAY is acting upward. So I am taking positive. Upward I am taking positive, friends. This 60 kilonewton is acting downward. So minus 60 downward. This 100 sin 53.13 downward again. This is also negative. And this RB is acting upward, so positive. that all equal to 0. Now RA and RB are positive, so I can write down like this: RAY plus RB. Now this part will go on right hand side. So if you calculate this value, it is going to be 140. So it is equal to 140. So this is our equation number 1. Now we'll be using third condition, that is moment of forces about the point equal to 0. So for ease of solving, I have taken point A and the moment of forces about point A, friends. So summation of moment of forces about point A equal to 0. Here this force will rotate the beam in the clockwise direction. This force will also rotate the beam like this clockwise. So these are going to be positive moments, and RB is going to rotate the beam in the anti-clockwise direction. So that will be anti-clockwise, means negative moment I'll be considering. So let's do it. How we can calculate? So RAY will not cause any moment. RAX will also not cause any moment. Okay, because they are acting at same point A. This 60 kilonewton will rotate the beam in the clockwise sense. So 60 into 2. So I'm going to write plus 60 into 2. It is plus because it is clockwise. Now this 100 sine 53.13 is acting over here at this point. I have shown here, but actually they are acting at this point. Point of application is this point. This point is point D, friends, and this point was point C. Okay, so they are acting at point D. So 100 sine 53.13 into this distance, again clockwise, so positive, into distance is what? 3 meters. And RB will rotate the beam in anti-clockwise sense, so minus RB times the distance from here to here is 5. So if you now see here, we have only one variable RB, so you can find the value of RB from here. This was clockwise moment and this is anti-clockwise moment, that is why I have taken negative. Okay, so now in this equation we have only one variable, that is RB, so we can find the value of RB from here. So from here I can say we'll calculate this value and that divide by 5. So if you solve this and find the value of RB, it is going to be 72 kilonewtons. Simple calculation, friends. Okay, so now we got RAX, this one, we got RB, the vertical force. Now RAY need to be calculated. So I can substitute the value of RB in equation 1 and I can calculate RAY. Therefore, from equation 1, we will be getting RAY as 140 minus 72, and that is equal to 68 kilonewton, friends. So I have got final answer RAY equal to 68 kilonewton. So all that forces required to show the support reaction we can easily calculate by using condition of static equilibrium. So you can use similar procedure to solve the problem when the inclined loads are given to you. Thank you very much.